We are going to work on the dimension of physical quantities like mass, time, length, breadth, height, radius, area, volume, density, velocity, acceleration, force, pressure, momentum, work, kinetic energy, impulse, moment, couple, potential energy, power, surface tension, stress, strain, and Young modulus. Some of our quantities have just a single dimension, like the mass, time, length, breadth, height, radius, and area. They all have a single dimension, same as your distance and displacement as well. Distance and displacement are the same thing as the length between 2 points. Only distance has no direction, but displacement has direction. So the dimension of our mass is m. So we represent it as capital letter M. The direction of time is t. The dimension of length is L. So distance is also L, displacement is also L. So if you look at the dimension of height, the dimension of height is also L. The dimension of breadth, L. The dimension of radius, also L. Now let's look for multiple dimensions like area. Area is the same thing as the length times breadth of a shape. So length times length will now become what we are working with, which is L square, because breadth is also length. Volume is length times breadth times height. But in dimension, everything will be L. That will be length times length times length, which is the same as L cube. Next is density. Density is the mass per unit volume of a substance. So that will be mass over volume. The dimension of mass is m, and that of volume is L cube. So that is the same thing as saying mass times 1 over L cube, and from indices 1 over L cube is the same thing as L raised to the power minus 3. Next on our list is speed. Speed is distance per time, or distance all over time. Distance is L and time is t. So L over t is the same as LT minus 1. So LT raised to the power of minus 1 is the same thing as L over t. Velocity has the same dimension unit as speed. So velocity is displacement over time, which is a different formula for speed. But both displacement and distance have the same dimension and unit. So that is also LT minus 1. Now we'll go to acceleration. Acceleration is the change in velocity per time. So change in velocity would still have the same dimension as velocity, which is LT minus 1 over time. So LT raised to the power minus 1 times time, or t raised to the power minus 1. That will be L, you pick 1, add the powers. That's minus 1 plus minus 1, which will give us minus 2. Next on the list is force. Force is the product of mass and acceleration of an object. So mass times acceleration. We know our mass as m and our acceleration as LT minus 2. So the product of both should give us mLT raised to the power of minus 2. Next on the list is pressure. Pressure is the force per unit area of a substance. So that should be force over area. Force is mLT minus 2 over L square, which is our area. Now, if you are to write out that in a straight line, it will be mLT minus 2 times L raised to the power of minus 2. So L and L, we are going to pick one, add the powers. So that should be mL1 plus minus 2, which is the same thing as 1 minus 2. Then our t raised to the power of minus 2. 1 minus 2 is the same thing as minus 1. So that should be ml minus 1 t minus 2. Next on our list is momentum. Momentum of a substance or a moving object is the product of mass and velocity of that object. So our mass is m and our velocity is lt raised to the power of minus 1. That should give us mlt raised to the power of minus 1. Now note, momentum and impulse, they both have the same dimension and unit. So next on our list is work. Work is force times distance. You can represent it as d or s. So you can choose to change your d as s. So sometimes the symbol of distance is s, sometimes it is d. So force is mlt minus 2 and distance is l. So when both are multiplied, you pick one L and add the powers, which is 1 plus 1, which will become ml raised to the power of 2, t raised to the power of minus 2. And next on our list is kinetic energy. That is half the product of mass times and the square of velocity. So half the product of mass and the square of velocity. So I'll write out my half. Half has no dimension. Any number is not reflected on our dimension. So half times m times v. So our v is lt raised to the power minus 1. So when you square it, it will be l times l and t minus 1 times t minus 1. So on squaring that, we should get l squared t minus 2. So the entire thing now will be ml l squared t minus 2. So the half there has no effect. The half is just telling us it is half of what we have there. But the actual dimension is ml to t minus 2. Impulse. Like I said earlier, impulse has the same dimension as momentum. So impulse is the product of force and time. So force is mlt minus 2 and your time is t. So if you multiply both, it should be mlt minus 2 plus 1. That should be mlt minus 1. Next is moment. Moment is the product of force and perpendicular distance. So that's force times perpendicular distance. No matter the type of distance, distance is distance. So force is mlt minus 2 and distance is l. So that should give us ml2 t raised to the power of minus 2. Note, moment, couple, work, kinetic energy all have the same dimension. Couple is the product of force and one of its distance. So a couple produces circular motion. It is two forces of equal magnitude acting in opposite direction, parallel to each other. Potential energy is the product of mass, acceleration due to gravity, and height. So that's m times lt raised to the power minus 2 times l. So that should give us ml2 t raised to the power minus 2. Potential difference has the same dimension as work as well. Surface tension is the force per unit length acting perpendicularly on the surface of a liquid. So we are going to work with that definition, force per length. In writing out the dimension of force is mlt t raised to the power minus 2 over L. So that should be ml t raised to the power minus 2 times L raised to the power minus 1. So if you pick out L, it will become 1 minus 1, which is 0. So that will be ml 0 t raised to the power minus 2. Anything raised to the power of 0 is the same thing as 1. So that becomes mt raised to the power minus 2. Now we go to elasticity. And under elasticity, we know stress as force over area. So stress is the same thing as force over area, which is also the same formula for pressure, meaning stress and pressure should have the same dimension and unit. So force is mlt minus 2, area is L square. So that will be mlt minus 2 times L raised to the power minus 2. So that will be ml1 minus 2, which is minus 1, times t raised to the power of minus 2. Strain under elasticity as well. Strain is extension over length. Both have the same dimensions, so strain is dimensionless. Strain's dimension is 1, which is dimensionless. Last but not the least, Young modulus. Young modulus is the ratio of stress to strain. So in elasticity, Young modulus is the ratio of stress to strain. That will be stress all over strain, which is the same thing as ml minus 1 t minus 2 over 1. So our answer will remain the numerator. The numerator is ml minus 1 t raised to the power of minus 2. So that will be ml raised to the power minus 1 and t raised to the power of minus 2. Our next video would be how to use dimensional analysis to derive formulas.